Welcome to this introduction to Visual Expert for Oracle. Let's start with a couple of slides to see some key concepts and then we'll do some clicking. How is this working? First of all, Visual Expert will use some code parser component that will read and understand the code in different languages. It will analyze the structure of the database, the PL SQL code, the triggers, etc. This will extract a very detailed descriptions of all the items composing the code and the dependencies and the structure of the database and store it into a dedicated database that we call a repository. Then this information is available for developers and users to use on-screen features or to export and put together this information in different type of document. And we will see a few examples of them. This can all happen on a single PC, and that would be the case, for example, if you try it with a small volume of code. But in the real life, we usually have the repository installed on a server, one instance of Visual Expert also running on this server to analyze the code on a regular basis, and then all the team members that need to use the Visual Expert services will install a copy of Visual Expert on their PC, connect to the repository, and use the services by leveraging all the information found during the code analysis. The analysis can be refreshed on a regular basis, as I mentioned. There are different strategies, command line, you can use plugins for Jenkins. You can also schedule a job with GitLab. So there are different ways of regularly refreshing the code analysis so that every team member get a fresh vision of the code. What are those services? There's hundreds of different features and services available. So to make it simple, we group them into a few categories. Once the code analysis is done, you can use different type of service to run impact analysis to evaluate the consequence of a change before or after you make it. You can explore those dependencies, generate CRUD metrics. I will show you a few examples right after that. You can also document the code, which of course could consist in generating and reading documents. But you can also, and that would be even more flexible and powerful, use the Visual Expert UI to explore the code dynamically to understand its inner working, the dependencies. And for that as well, I will show you some examples. You can compare two versions of a certain code or two schemas or two databases if you like. There's a large range of features that consist in reviewing the code under different angles to find security problems, maintainability issues, performance. There's different ways of improving the security and the quality of the code. You will find bugs as well, for example. And finally, we will monitor the performance of the code, and I will explain how this is working. Basically, we will take some data from the database about what's running fast or not and mix that with the code analysis to pinpoint in the code the bottleneck that slow down your application. Now let's take a look at the Visual Expert UI. So the first step when configuring your Visual Expert installation would probably be for someone to install Visual Expert on a server and create a project to indicate where is the code you want to analyze, how to connect to your database, for example, which schema should be analyzed or not to detach a certain perimeter of code analysis. And for that, this particular person that would configure the project would use a wizard in which you can select a language, select a certain data source, because you could find the code from in a database or files or source controls. And there are additional steps to select precisely the code you want to analyze and schedule it possibly, etc. But in this video, we will primarily focus on using the code analysis once it is done. So on a client PC, when you install Visual Expert, what you would do the first time is connect to your repository. You will have to get the detail to connect to that particular repository. And then you will find immediately the existing project and you will be able to use the existing code analysis that were done before. Then you will get this UI here. So let me explain quickly the main part of this UI. So in this part here, you have a vision of the component in a tree view where you see object and dependencies, but it's primarily a vision at object level or component level of your application. And then when you're selecting an object that includes some code, you will see this code right here in the source code view. And on the left side, there is a very important navigation bar. This is where you will be able to execute queries if you like, or use some features, some services that will query the Visual Expert repository to retrieve the information you're looking for, and that will put it together in the tree view. And you may notice that if I'm selecting a procedure, this is the list of features that are making sense, that are appropriate for a procedure. But if I'm selecting a table, I may have different questions, different information would be relevant for me to see. In this case, the list here is different. And like that, anytime I'm selecting an object, a relevant list of features would be proposed. So this navigation bar is contextual to the type of item selected in the tree view. All right, let's start with a couple examples. We'll start with the first category of feature related to impacts analysis and cross-references. Let's say that I need to evaluate the consequence of changing something about a column in my database, maybe the size, the data type, or the name of the column has been changed, but I need to know where this column is used anywhere in the schema or in the code of my database. So first of all, I can open the list of tables here. And for one particular table, I can list the columns available for this table. Let's say this column is what I would need to analyze. So I need to go to navigation bar and the section cross-reference, because if you remember the categories of feature in the navigation bar, the feature are grouped by category, cross-reference, documentation, etc. So in this case, we're in the cross-reference section and we'll go to impact analysis. This will create a tree view with all the items referencing this column placed in a container hierarchy. So for example, here I have a select statement. This select statement is referencing the column. You see that with a red pin and a yellow background. And this select statement is contained in a view, that I can see here. That's the DDL statement to create the view, placed in a schema, database, etc. And like that, I will have other object referencing the column. So this is a PL/SQL block with a reference here. This is a trigger, another trigger. In this case, there are three references to the column ID. That's a table with a foreign key constraint. This is a package. And you can see that this package here is including 13 references. And you can see on the right-hand side here, the line number. If I have a long piece of code, a large piece of code, maybe I cannot see all the references, but I can click here to scroll down and see directly this particular reference. And by the way, you can notice that in the source code, we've been adding tooltips to indicate type of item we are overing, where they are defined, and possibly some additional information. So this is for the table, and you have like that all the active items that we understood while reading the code coming with a corresponding tooltip. So coming back here, this is an example of impact analysis to see the reference for a column. But I would like also to draw your attention on the fact that this is very different from searching for a string, because if I were to search for the string ID, there's a local search here that I can use. And you see that the string ID is found in many places. In the application, I would have thousands of occurrences for this string search. But impact analysis, on the other hand, is focusing only on the exact reference to that particular column. It's not a string search. It is based on the grammatical understanding of the code and showing exactly what you're looking for. It's way more accurate and you're saving a lot of time compared to a string search. Okay, coming back to the concept of impact analysis. So this is the way of finding references to a column. But I can do the same for any type of item, whether it's, for example, a table, cross-reference, impact analysis. I have the same. Or a procedure, for example. So if I'm opening here this list of procedures, I can execute also an impact analysis, and the concept is the same. I have here the result placed in a container hierarchy, so two stored procedure in two different packages. And if I click on this one, I would see exactly where the reference to the stored procedure delete employee by ID is located. Now let's see another example of leveraging the information about dependencies between objects in my database. I have the possibility to create what we call a CRUD matrix. You see there's a feature here, CRUD matrix. CRUD stands for create, read, update, delete. And that will show me which object is using a table and how it is using it, but at a higher level than the impact analysis, because we will export this information in an Excel file with a two-dimension matrix where you would see on columns the tables and for each row the object using them. Let's see what it looks like. So you see, for example, the table product is here in this column. And right here, you would see the object accessing this table and how they are accessing them. So this file is including some code that is reading and updating from the table product, which means there are some select statement and update statement. And if I scroll down, I would see here that this is a procedure inserting, creating from the table product. Another procedure deleting from the table, reading, etc., etc. So could be procedure, triggers, views, any type of object that would at some point reference or access the table would be listed here with the type of access. So like I said, this is a higher level than the impact analysis. The impact analysis would go at the instruction level. This is more compact. And for example, if you were about to refactor a certain business process, product management, and let's say you want to check out where in the application you are deleting from the table product, this is a way to find it. And then you can zoom in with an impact analysis or where your traditional development tool if you like. Now, there's another type of matrix that you can generate and export in Excel. And this one is for analyzing dependencies between object and object, as opposed to object and data before with the CRUD matrix. So you can come here, select some object containing code, and instead of the CRUD matrix, still in the section cross-reference, you would go to object dependency matrix. The concept is quite similar. That will generate an Excel file with a two-dimension matrix where you would see which procedure, this is the callee, is called by certain objects. So for example, here, this init procedure is somehow calling that many objects that I can see in each columns here. Now let's see another way of leveraging the dependency information. This time, it's not for analyzing the consequence of a change. That would rather be to understand the inner working of the application. So let's say I need to work on a certain business process, and this business process is starting when the user is executing a certain action, executing a procedure, but this procedure is calling another one, then another one, etc. There is a long chain of call. And if you have to understand and maintain this part of the application, first, you need to have a clear vision of this chain of call. And if you have a large application, chances are you may end up with tens or hundreds of objects calling each other, which is very long and complex to rebuild manually. So what you can simply do here is start with the procedure executed initially. Let's come back to the one we tried before. And you would go to the group cross-reference, and this time you would go here, use the call graph. And this will generate another tree view where you would see one by one the chain of calls, all the items calling each other. Let's take a look. This procedure here you see includes the delete statements. That's this one, referencing the table employee that you can see here. Okay, so far so good. But then this table is tied to another table with a foreign key constraint. And another foreign key constraint will tie it also to this sales order item table. And if we update this table, then there's a trigger executed here. This trigger is referencing a start procedure. The procedure is inserting in this table, which in turn will generate or execute this trigger. So we are using now a very small sample code, very small piece of code. So it's just a matter of 10, 20 objects calling each other. In the real life, it's going to be much bigger. But even like that, you might be wondering, how come when I'm deleting an employee, at some point I end up, inserting in the log table? Well, that's why. This is all the chain of code explaining why. So the longer, the bigger the application, the longer the chain of code, the more useful this type of graph is going to be to understand the inner working of the application. Now, I would like to show you something else about this feature here. We call that a macro. A macro is this kind of button with a query that is executed against the Visual Expert repository. You may have noticed that sometimes there is a small button on the right with a range. Those are parameters for that particular macro. It's a way to customize the result of the macro. So in that case, if I'm clicking here, what do I see? I have a list of items, type of nodes that will be displayed in this tree view. So if I want to go deeper, and for example, I need to understand which parameter and variable are used down the road and maybe columns as well, I just check these boxes, executed, and run again. Then I will see additional information where I can see here the columns. I can see the variables, the parameters that are involved somewhere in the chain of code. So this type of graph, this result is presented in the form of a tree view. But I can also instead present the same result in the form of a diagram. And you would see that here I do have parameters to select different type of diagrams, different ways of representing box and arrows to show the same result. You can try them out and see what is working best for you. But anyway, at the end, you will get this diagram and it's usually quite big. So what you can do here is click on the full screen button to detach the diagram, adjust the zoom factor if you like. You can even open an editor to edit this particular diagram. You can move blocks around, you can remove some of them, you can add manually additional blocks, comments, etc. before you export the diagram into PDF or PNG and send it by email to your colleagues, for example. So what's interesting with this diagram is that it's just not, a static graphical representation, it's still active. So if I'm reducing a bit the diagram, first of all, what I can do is if I select one block, I can see what is it connected to. Because the bigger the chain of code, the more diagrams you will have on the screen, and it can quickly become a bit difficult to figure out what's connected to what. So by simply selecting an object, you see what is connected to this particular object. And the second thing that's interesting is that this diagram is still synchronized with the source code here. So if I'm selecting another block, I would see the corresponding source code. That's for this table. I would see the real statement behind it, etc. So block by block, I can keep exploring the diagram and viewing the corresponding code if needed. And you have different types of diagrams available. So for example, I can select tables and in the section documentation, I can generate a data model to document this schema and the way data are organized together. Let's detach with the full screen button. By default, tables are collapsed. You can open them one by one or expand all the tables and again, move them around. So you would typically have the same classical representation with columns for n key dependencies, and you just have to export it, print it whenever you like. Now, we've been looking at this whole graph feature right here. So again, this is showing that this is calling something else, that is calling something else, etc. What if I need the other way around? I will need to know what is called by instead of looking at what is calling something. So if I'm starting here, I would like to see which object, you know, is calling that in a recursive way. And instead of call graph, I would use here reverse call graph. So it's exactly the same concept, but in the opposite direction. So it means that this is called by this, which is referenced by this and referenced by this, etc. It's pretty much like an impact analysis, but at multiple level, because the impact analysis we tried at the beginning was just one level. I'm selecting column and I see all the items using this column. Here, it's exactly the same, but for each item we found, we keep digging. And is there something else calling this object? Yes. And then if we find something, is there something else calling this object, etc., in a recursive way. I would like to show you some collaborative features. So we've been using Visual Expert for impact analysis, call graph, etc. So that was, for example, me doing some clicking right here, querying the repository, getting the result, and building like that a tree view with all the results that are interesting to me. But what if I need to share the result and possibly share the workload of a given code refactoring with several colleagues? Then I will show you how I can take the view or the tree view that I just created, upload it to the repository so that other colleagues can download it and keep browsing based on my result. Let's take an example with an impact analysis as we did before. So I'm selecting a table, then a column for which I'm running an impact analysis. And let's say that I would like to share this result with some colleagues. So I can detach at any point a part of the tree view with a right click here and by selecting the option create view from selection, which is going to create here the subset of the tree view that I was selecting as a separate tab page. So let's say that I don't want to share everything in one package, but rather send to colleague number one some items that I would like him to take a look at. Let's say this, for example, right click, create view from selection. And that's going to be something that I can rename impact analysis ID part one. Okay. Then I will continue with a second selection that I may share with somebody else, like that. Okay, let's call it like that. Fine. Now, what I'm going to do is I'm going to share this view to upload it in the repository. And so part one is going to be for my colleague number one, teammate number one. Okay, save, do the same here. And that's going to be part two for teammate number two. And then I can explain, please check this out and do something. And that's it. Now, both views are now available in the repository for anyone else in my team to download them. So they will come here, they load a view and select if that's colleague number one, then it would pick the view that is main for him, load it, and that's it. And this is not just a static list, it's an active list and it can keep browsing because we are connected to the same repository. So we can keep exploring using the same features, running impact analysis if we want to. Anything available in the initial client is available to all the other clients because they are sharing the same repository. So that's a way of collaborating and sharing some work or your refactoring for a large piece of code. Now, let's talk a bit more about documenting and understanding the code. So we saw some macros in the tree view to understand, for example, the chain of call, the data model. You can also generate document, HTML document to document your application. And for that, there's a window that you can open here to set up some parameters, such as, where do I generate the document? What kind of document? The style, the language. Should I generate for the entire project or just a selection of object that I made here in the tree view? I can schedule this documentation to refresh it on a regular basis. And once it's done, this is pretty much what I get. You would see, categories of object for each object. Then you can drill down and explore furthermore. This is column by columns. You have the description of the DDL statement for this table, triggers. So you can check out the triggers for this table. You have the items referenced by the table and the item calling impact analysis, the table. And anytime there's an active item, you can click and see what's behind, variable, source code for this function, what is called by the function, and what is calling the impact analysis, this function, etc. And you can keep browsing like that, object by object, to learn more about the procedures, for example. This is what we saw before with the parameters, the source code, reference, impact analysis, etc. Now I will show you how to review the code to improve its quality, security, stability. And let's start with some background explanation. So if you go to the settings, more settings, you will see a number of rules per language. In the case of Oracle, there's about 200 different rules that are meant to identify certain issues for maintainability, vulnerabilities, bugs, different categories with a certain severity, critical, major, minor, etc. And for each rule, anytime we find an issue, we've been estimating the technical debt, which is how much to fix a maintainability problem if we were to fix it, and what is the remediation cost. This is when we want to fix vulnerabilities and bugs. This estimation, you can adapt it, change it any way you like. Bottom line, anytime we refresh the code analysis, we will check each piece of code against all those rules automatically. And at the end, you can view the result at different levels. First of all, if you come here, select the application level, you will see this dashboard. And this dashboard will give you high-level indicators. So on the top, you would see indicators about the reliability. Did we find some bugs? Security. Did we find vulnerabilities, maintainability, about quality issues, etc. I can click here to get the list, but let me keep explaining a bit further. You have a breakdown of all the issues by severity, critical, major, etc., and a breakdown of the issues by type, maintainability, bugs, vulnerabilities, security warnings. Then I have an estimation of the remediation cost, because if you recall, for each rule, for each issue, we have a unit time for fixing this problem. If we calculate the total, this is what we get for this project. If we were to fix all bugs and vulnerabilities, we have an estimation of the remediation cost and the technical debt if we were to process and remove all the maintainability issues with a breakdown by severity. On any part of these items of this dashboard, you can double click to drill down. So for example, here, if I drill down to learn more about the subset of problems that are critical problems, if I double click, I get this. This is a trend. Anytime I have a new code analysis, there's a new dot in this line right here. And I can see if it's increasing, decreasing, how it's evolving. And the same comes for cost, remediation cost and technical debt, how they are evolving over time. Then still for this subset of critical problems, I have the list here of corresponding rules for this severity. For each rule, I have the number of issues found in this project. So if I were to click on one of those rules, so I don't know, let's take this one. What I get is this. So I have a description of the rule with non-compliant example and compliant example to learn more about what's expected. And for each type of item in the list, if I click on them, I see the source code. I see with a highlight the place where there is the problem found and a description with a tooltip of the rule, the severity, and the category of problem found. Then the developer can take it from there and fix them one by one. So that's one way to navigate in the result. But like I said, I could click somewhere else in this dashboard. For example, show me all the bugs. For example, okay, I found a certain number of bugs. So then I have all the rules corresponding to this category of problems. And for each rule, there is a number of problems found. So here, this rule has been broken 19 times. If I double click, so first of all, I can check out the description of the rule and what is expected, what's not expected. And again, if I click on the code, then I get a highlight where the problem is located, etc. for each problems one by one. And finally, there's a third way that I would like to show you to navigate in this result. So in the tree view, you have a node here called Code Inspection for Oracle. When I select this node, there's a new list of macros appearing in the navigation bar. So for example, this macro, of course, I could list all of them, but if I'm coming here and open the parameters, then I can choose whatever is making sense for me. So for example, show me everything about, security warnings and vulnerabilities for critical and major problems. And this subset is appearing here. There's only 5 of them that I can fix by, double clicking, opening, viewing the code and fixing them. Okay. So this type of parameters and filtering is a way to prioritize whatever improvement you want to make in the code, because traditionally there are a lot of low level problems, mainly due to the maintainability. You can see here we have more than 2,000 problems. Chances are you're not going to have time to fix them all. So you need to prioritize. This type of parameter is a way to filter out what's most important for you and address the most critical problems, the most urgent problem first. Now, this is a way to leverage the rules for your code, but there's an additional set of feature to review the code. It's not method by method where we would confront each method, each functions to a certain set of rules. It's more of a global vision or a different angle. Let's take an example. For example, if I'm coming here, selecting the procedures, I can find unused procedures, meaning those procedures Visual Expert could not find any dependency. They are not used call reference in any way. Maybe you need to double check. They could be called from outside a database or by another program, but at least if you have like 2 or 3% of the procedure that seems to be unused, maybe you want to double check and possibly clean up some dead code. You can also estimate the volume of code, number of lines of code for a certain perimeter, either it's for one procedure or category of object or package. If I'm taking a package, then I can see how many lines of code for that particular package. I can check naming conventions to see if the code is easy to understand with the proper prefix. I can find out if some methods do not contain any comment. And if I go to the table, for example, let's pick a couple different examples. I can find if some table need additional primary keys. Some of them may be unused. Some index may be unused. I can find which are the most used tables right here. So you can check this out with your code, but this additional set of feature is also coming on top of the rules to review your code and improve again quality, security, stability. Let's take a moment and talk about DevOps. So imagine you're in the context of continuous integration, or your company is simply using a source control to store the code and generate builds on a regular basis. You might want to automate the code inspection on a regular basis, no matter where the code is coming from. And you can do that with Visual Expert. You can trigger the code inspection automatically if needed. So, of course, that could be on demand by using the UI. You can use an automation server like Jenkins or GitLab to do that and add a job to start anytime you have a new build, a task to inspect the code and get the results. You can use the Visual Expert Scheduler, or you can use the command line to integrate it with any kind of system who's capable of calling an executable with the command line. And then you can fetch the code from any type of source, whether it's located on the network in a shared location, in the database directly in different source controls. And that is going to analyze and review the code automatically to generate the result in the repository, for instance, anytime you have a build in the context of a continuous integration workflow. Now, the last category of features that we're going to have a look at for this presentation is related to performance tuning, where we will try to identify the slowest piece of code, the bottlenecks, the problems that slow down your application in order to improve them. To do that, we have been configuring our Visual Expert project to not only read the source code, but also fetch from the database some statistical data that the Oracle database is generating automatically by default. For any type of Oracle database, there's a certain system table that gives you this information about which object has been executed, how many times, and how long the average execution time for this particular object. So we combine this performance data together with the source code to get some insight about the problems, potential performance problem in your application. For example, you can select the procedures, and if you go to the navigation bar this time, we're going to go in the performance analysis group, and you click on the slowest code. This tells you the top 10 or top 20. There's parameter again where you can adjust the size of this list, but it's going to be the top slowest object right here. If I take a look at the code, there's possibly a very long list of code with number of queries. This is why I can break it down to queries and find that this is the one that is slowing down this particular procedure. Now, this is one way to look at the performance tuning and identify priorities, but there may be another scenario. Let's say you have a user feedback and they're complaining about a particular feature. They're clicking somewhere and it's taking a long time before the application is responding. So we're again, in that case, facing the chain of call where many functions are calling each other. So in a real life big application, if you have hundreds of functions calling each other, the overall process is slow. Okay, fine. But where is the problem coming from? Which of those functions are taking a long time? We can use Visual Expert here. Let's open or select the procedure, the same as we did before. If you recall, we've been using this with a call graph to view the chain of call. Fine. But now instead of the group cross-reference, we're going to go down to the performance analysis and we're going to execute here the call graph with execution time. So it's pretty much the same result plus an indication of the time for each of them. And visually, you can identify in this chain of call where the bottleneck is. And this is the statement, the query, or the piece of code that you need to optimize. Another example of feature that can help you improve performance is this. So let's take a list of table and check some of them to see if we can find some missing indexes that would slow down the performance. And what does this mean? If you can look at the tooltip here, it says that these columns need an index because they are used in a join, a where clause, a group by having, order by clause. And all those cases, all those queries, if there's no index, the database is going to run a full table scan for this column, which is very much time consuming. So if we take the example of the table product, it says that 3 columns need an index. No matter if there's a simple index or composite index, there's no index at all right here. Now, if I want to double check, are you sure I need an index here? So let's go with an impact analysis. And I don't know, let's check one by one. So for example, here you have a group by clause referencing that particular column. This means full table scan. This means performance problem if there's no index here. And it goes like that for each column of this table. So from time to time, you can review your database and double check if some index should be created because the code is evolving, queries are evolving, and it's quite possible that new SQL statements are now using a certain column in a where clause, whereas it was not the case last time you checked. So that's a good practice to do that from time to time. And the last example I'm going to use today for talking about performance tuning is the following. It's another scenario. So the DBA comes back to you and say, there's a particular SQL that is very slow to execute. Please improve it. Fine. But the problem is the DBA can only send you back the SQL itself, but there's no information, no indication where the SQL was created. So you can come back to the same table that is, for which the query is causing a problem. And if you come to performance analysis, you can find the slowest SQL using this table. And in that case, there's at least a few of them that may need to be improved if possible. It's not always possible, but at least if you can pinpoint the one that hopefully would be improved. That's already important. Anyway, if you want to know where they're located, you can select them and simply go to documentation and locate. And this will tell you the database, the object, and the query itself to know which object I should open and possibly improve. So that's it for this quick introduction to Visual Expert for Oracle. For more details, I would suggest taking a look at the website for two things. Number one, if you go to this page, you will have a brief description of the key features in case you want to discuss that with your colleagues and figure out if that's of value for your project. But most important, in this menu here, you will see all the tutorials, and there are a lot of them, where you can search by keyword to find whatever you're looking for. If you want to try Visual Expert, you can download a copy here. And if you need some assistance, you can contact the support, create a ticket, and we will be there to help you. Thank you for watching.